Finite Element Analysis of a Parabolic Fin by Katy Sabo and Andrew Poteracki. A parabolic fin was used for our design, and we used the process of iteration to find an optimal length and radius. The fin was analyzed in aluminum and copper in ambient temperature of 20 degrees Celsius with a convection coefficient of 50 watts per meter squared Kelvin. Using SolidWorks, we modeled our fin and imported it into ANSYS. The team set the radius of the fin constant at 5 meters because we wanted the slope of the fin to be gradual. By keeping the radius constant, we were able to find the fin length and find the optimal solution between both materials. 8 trials or iterations were ran in order to compare the fin length and minimum temperature and find an optimal solution. We wanted to reduce the minimum temperature to as close to the 20 degrees ambient temperature and raise the max heat flux as high as possible without sacrificing a large increase in fin length for only a few degrees difference in temperature and heat flux. Thus, the optimal length was found to be 0.3 meters for both the aluminum copper and can be seen in the tables and graph below.
For the copper fin, we achieved a minimum temperature of 70.66 degrees Celsius and total heat flux of 373,000 watts per meter squared Kelvin at our optimal length. For the aluminum fin, we achieved a minimum temperature of 38.35 degrees Celsius and a max heat flux of 300,000 watts per meter squared Kelvin at our optimal length. Using the adjacent equations and properties of each material with the geometry of the fin, the efficiency for each material is found. Aluminum was found to have a 35.8% efficient fin, and copper was able to have a 45.9% efficient fin. The computational heat flux values were calculated using the adjacent equations from the heat transfer textbook. These allowed for us to find the below computational efficiencies for aluminum and copper. Using percent error, the differences are shown adjacent. The huge discrepancies most likely come from where we applied the convection over the fin in the ANSYS program. The values we were using for the maximum heat flux from ANSYS were much larger than the heat flux of the fins that were actually calculated.